Let's go. Let's try this. Number 3. All right, so if I take the derivative of this, right? So say this is f of x, then f prime of x would equal 6x, right? And then if this is g of x, right? Then g prime of x is going to equal 16x to the third. Okay, so that's pretty easy. Now, we have to know the rules of the game, and the rules of the game are this. What are f of x prime is equal to f prime of x times g of x minus, right? Minus f of x times g prime of x all over g of x squared, okay? So what that means is I'm going to put, and I did this before with a group of kids, and I said, let's let f of x be purple, f prime of x be green, and g of x be red, right? And so the way this looks now is that the g of x is red, right? F prime of x is green, okay? And the minus is still blue. The g prime of x is still blue, right? And the f of x is purple. Okay, and then the g of x was red, right? So that means this guy is squared, right? And so when you color code it like that, it can help you organize things better. So, like for the first one, we're going to have 6x times the g of x. So g of x is red. So that would be 4x to the fourth plus 4, right? And then we're going to have minus, of course, all over, right? And this is going to be a big factor, okay? So minus f of x, which is purple, right? Which is 3x squared, right? Times the g prime of x, so the derivative of the bottom, which is times 16x cubed, right? All over the original g of x, 4x to the fourth plus 4 squared. Now when I did this the original time, the first derivative, was perfect. I mean, it was flawless. And then I went sidetracked, and reducing the function went weird. So this was all perfect. So now let's try to reduce the fraction in a good way. So, what am I going to do? Well, what am I going to do? The first thing I can do is start to combine some terms, okay? So let's look at, everybody on the block gets the paper. So that'd be 6 times that is 24x to the fifth, right? And plus 24x, okay? And then remember this is minus all of this. So let's just say minus, let's just put these two together real quick. So then these would be 3 times 16 is 48, right? And then x to the fifth, right? And before, well, let's just do that. And then let's put these together. So this is squared, so that's 16x to the 8, right? Plus, and then plus 16. And then it's 2 times 4 times 4. So it's 4 times 4 is 16 times 2 is 32. And then that's x to the fourth. Okay? So that's great, but we can start pulling some things out. Now, I can also put something together. So let's put something together first. Okay? So the first thing I can put together is this, right? Those are x to the fifths. So let's put those together. So that's y prime is equal to negative 24x to the fifth plus 24x, right? And then there's nothing to put together there, so we just have the same thing. X squared, or 8, sorry about that, to the 8 plus 32x to the 4th plus 16. Okay, so that's great. Now, what goes into 16, 32, and 16, but also goes into 24 and 24? So this is where I like to do my upside down division. And the reason is I was teaching this to a lot of kids when I was teaching pre-cal for other places. And this is when I came up with upside down division still works for calculus kids. And it takes into effect both the top and the bottom and all the factors. So you're kind of thinking, well, what goes into 16 and 32? Well, 16 does. Okay, but does 16 go into 24? And you're like, no, but 8 does. So I know that 8 goes into 16, 32, and 24. So I'm going to divide this by 8. And so when I divide everything by 8, I get negative, what do I get? Negative 3x to the 5th plus 3x, right? All over 2x to the 8th plus 4x to the 4th plus 2. Okay? And that might be the right answer. Instead of the way that I did it the last time was so cumbersome. So yep, negative 3x to the 5th plus 3x over 2x to the 8th plus 4x to the 4th plus 2. So right there, clean and simple, pretty easy. I hope you enjoyed it. Much better way of doing it.